Hello folks, this is 2024 October November paper 1-1 and the question number is 37. The question is concerned with the chapter current electricity. As you can see from the setup, it says that a potentiometer circuit is used to determine the EMF E of a cell, and in this diagram you can see E here. E is over here, so we have to determine this thing. Okay. So the circuit includes a second cell of EMF 1.5 volt. This is the EMF of 1.5 volt. Is the master cell, driver cell we call as, and the small r for this thing is 0.50 ohm. That is connected to a uniform resistance wire XY. So this XY is the feature of a potentiometer, because potentiometer is a device whose main feature is a conducting wire whose resistance depends on your length, and that is obtained by its uniform cross section. So when you make cross section uniform, R proportional to L. So that's what it says. Now then the resistance wire XY has a length 0.96 meter. So this whole XY from here to here is 0.96 meters, as is said here, 0.96 meters. And resistance of this much. So R this and L this. The movable connection Z is moved along wire XY. So this Z can move along this wire XY. The galvanometer reading is 0 when length Z is 0.64. So when it is at 0.64 meters, this reading is 0. Galvo reading is equal to 0. What is the value of E? So if so, what is the value of E? So when the galvanometer reads 0, the condition of the potentiometer is that this E should be equal to Vxy. When the galvanometer is 0, that means I through the galvanometer is equal to 0 at that time. Now what is Vxy then? So this Vxy is this PD. So this Vxy is obtained as a result of voltage division. Voltage division among resistor this, and resistor this. So Vxy is obtained as a result of voltage division of this, and this. So when this and this combine, I have got this whole thing XY. So we have this Vxy should be equal to Rxz. So X is this, Z is this, Rxz divided this whole resistance is Rxy plus this small resistance is small r. So Vxy equal to this much into, then the EMF of the source is this E. This E is a super E. It's a different sort of E. So that's why what I do is, yeah, so it is 1.5. Now I need to have this Rxz. So to have this, what I have is, we have, when the length is equal to 0.96 meters, the resistance is equal to 0.50 ohm. So when length is equal to 1 meter, the resistance will be equal to 0.50 by 0.96. And when the length is equal to 0.64 meters, R is equal to 0.50 by 0.96 into 0.64. So this thing is 2/3. So this is 2/3. So 2/3 of this is equal to 0.333 and so on ohms. So it is 0.33 and so on. So I should have used a 2SF, but for accuracy or precision, for accuracy mainly, I like to use 3SF here. So it is 0.33 ohm. So now our Rxz is equal to 0.333 ohm. So it will be equal to 0.333 divided, this is 0.50 plus small r also is 0.50 into this 1.5. So equal to 0.333 by 1 into 1.5. So it is 0.333 means 1/3 of this 1.5, which is equal to 0.5 volt. So this Vxy is equal to 0.5 volt, and if so, then E also is equal to 0.5. E also is equal to 0.5 volt. So this is how EMF is obtained from measured from a potentiometer. So the answer choice is available in choice number A. So choice A is the correct choice.